Welcome back to the program on series of digital supply chain. We are going to see today a topic on computer vision, which is also a part of digital supply chain. As you know, many of you, we have started a program on digital supply chain, which means how you can use a digital tool to enhance the performance of supply chain. And one of the aspect is a computer vision. As you know, many of you, the computer vision is already being in use. For example, if you use Google Lens and you spot a photo or image, it is able to recognize to highest possible accuracy, and it can tell what exactly is the item. And other practical application could be the facial recognition, and so many we may be already using but not aware that computer is behaving as a human and seeing the object. So in this aspect, let us understand some of the basics of computer vision and how it can be included in the supply chain application to enhance the performance of supply chain. So let me attach a screen. Apart from supply chain, possibly you are aware that social media, they have to handle different kind of data, starting from image, video, audio, and so many media, and they have the responsibility to ensure that the correct content are being used in any such applications. Okay, so they have a very high task and also a risk in classifying such a item and displaying them in the social media. Of course, you know, millions of video images are being uploaded every minute, every second. So those things must be automatically see that sometimes unwanted information passes on in the social media. That's where they are into trouble. Let us understand what is computer vision. It is a field of AI that uses machine learning and neural network to teach computers and systems to derive meaningful information from digital images, videos, and other visual inputs. It can be any form, including text. Okay, you can recognize the text. That's where text analytics also plays a important role in engineering. Possibly as of now, one of the important application could be seeing the defects or issue in the component. Of course, recognizing the component can be a ultimate application of computer vision. If AI enables computers to think, computer vision enables them to see, observe, and understand. And computer vision works much the same as human vision, except human have a head start. So, what is computer vision? It trains machines to perform this function, but it must do it in much less time with cameras, data, and algorithm rather than retina, optic nerves, and visual cortex like human being possess them. Because a system trying to inspect products or watch a production asset can analyze thousands of products or processes a minute, noticing imperceptible defects or issue, it can quickly surpass human capability. That is one more aspect, recognizing it accurately and also doing it fast. As you know, in the social media, things are happening so quick. So both are required, recognize fast as well as doing it quickly. So how does the computer vision works? It needs a lot of data because it runs analysis of data over and over until it discerns distinction and ultimately recognize the image. For example, to train a computer to recognize automobile tires, it need to be fed with a vast quantity of tire images and tire related item to learn difference and recognize a tire, especially with one with defect and one which is not having a defect. Okay, two essential technologies are used to accomplish a type of machine learning called deep learning and convolutional neural network or CNN. Of course, these are all part of our training in supply chain analytics program, which is also a part of digital supply chain. Machine learning uses an algorithmic model that enables a computer to teach itself about the context of visual data. If enough data is fed through the model, the computer will look at the data and teach itself to tell one image from the other one. Okay, a CNN else machine learning or deep learning model look by breaking images down to pixels that are given tags or labels. It uses the label to perform convolutions and make prediction about what it is seeing. The neural network runs convolutions and check the accuracy of its prediction in a series of iterations until the predictions start to come true. It is then recognizing or seeing images in a way similar to human. Of course, there will be a error to some extent. Maybe as application at the end of the session, we will see how the image recognition works in a real place. Much like a human making out an image at a distance, a CNN first discerns odd edges and simple shape, then fills the information as it runs iteration of its prediction. A CNN is used to understand single images. A recurrent neural network is used in a similar way for video applications to help computer understand how pictures in a series of frame are related to one another. How images are analyzed: a sensing device captures an image. The sensing device is often maybe a camera, but could be a video camera, medical imaging device, or any other type of a device that captures an image for analysis. The image is then sent to a interpreting device. The interpreting device uses pattern recognition to break the image down, compare the pattern in the image against its library of known patterns, and determine if any of the content in the image is a match. So when this algorithm works, it compares this image with the database of images available. So if we are showing human being, it can say a man or female, what kind of age approximate. Same, it can recognize animal, whether it's a cat or dog, something like that. The history of computer vision: by 2000, the focus of the study was just object recognition, but by 2001, the first real-time facial recognition application was developed. In 2010, ImageNet data set become available. This is a database having pictures or images of any item on the earth. So it's a huge database. If you want recognition, you have to upload this database and feed your image for comparison. Okay. Coming to the capabilities, one is the object classification. The system classifies the object in an image according to the defined category. For example, with the object classification, a computer could distinguish people from objects in a photo and determine how many people can appear in the photo. Maybe this is a starting step, because when you go to the higher end, it can also recognize a person and name the person, but it starts with object classification. Next one is object identification. The system identifies a particular object in a photo, video, or an image. For example, with object identification, the system would be able to not only distinguish people in the photo, but also analyze their appearance to determine the identity or traits of those people. Then it could be object tracking, useful in logistic and supply chain. The system analyzes a video to process the location of a moving object over time. For example, with object tracking, a parking lot surveillance camera could identify cars in a parking lot and provide information about the location and movement of those cars over time. Optical character recognition. Here, the system identifies the letter and the numbers in the image and convert the text into machine encoded text that can be read by other computer application or edited by users. So here, text analytics plays a bigger role, and artificial intelligence is going to play a major role in linguistics. Okay, maybe even handwritten script can be read by artificial intelligence. So as an application, Google Translate lets user point a smartphone camera at a sign in another language and almost immediately obtain a translation of the sign in their preferred language. Of course, the development of self-driving vehicles relies on computer vision to make sense of the visual input from the car's camera and sensors. It is essential to identify other cars, traffic signs, lane markers, pedestrians, bicycles, and all of the other visual information encountered in the road. IBM is also applying computer vision technology with partners like Verizon to bring intelligent AI to the edge and to help automotive manufacturer to identify quality defects before a vehicle leaves a factory. Of course, all this quality identification could be visual, and it may not be 100% accurate, because I am from a manufacturing background, and I feel still it is in nascent stage either to identify the components or even the defects to the full extent. Okay, because you may be surprised in a retail distribution environment. All item comes with a barcode, QR code, or even a RFID. In such case, it need not to recognize the item because it is read through the information available. On the other hand, if you go to the manufacturing industry, you may get an item without any barcoding or other data identification devices. In such case, these devices or technology may helpful in the future to identify the object, and also to find out whether the item is having any defect or no. Image classification sees a image and can classify it, for example, a dog, an apple, or a person's face. More precisely, it is able to accurately predict that a given image belongs to a certain class. For example, a social media company might want to use it automatically identify and segregate objectionable image uploaded by the user. This is what we have started, especially for the social media. They have a big task in classifying the items. Of course, there are other things like autonomous vehicle, for example, need not only to classify and detect objects such as pedestrian, other cars, and road infrastructure. They need to track them in motion to avoid collisions and obey traffic laws. Content based image retrieval uses computer vision to browse, search, and retrieve image from the large database. Possibly in the Google image, you are able to get what you want based on the search word. Okay, you can see some of the examples, some of which also include supply chain and logistic applications, starting from content organization. In agriculture, for example, images of crops taken from satellite, drones, or planes can be analyzed to monitor harvest, detect weed emergence, or identify crop nutrient deficiency. Maybe in the sports, object detection and tracking is used for the play and the strategy analysis. Text analytics or text extraction, autonomous vehicle in manufacturing. For example, it can monitor manufacturing machinery for maintenance purpose. Then augmented reality, physical objects are detected and tracked in real time with computer vision. In healthcare, photos or images captured by the other medical devices can be analyzed to provide help doctors identify the problem and make diagnosis more quickly and accurately. Like this, you have a lot of application. Of course, most popular which is being used currently is the facial recognition, and it can be used to apply the individuals. With this, I am closing briefly on application, but however, we can see. application using Python and AI in object recognition. Of course, this is part of our program on digital supply chain. For example, if you are loading an image, in this image you can see a car with a background. There are buildings and also possibly there is a river. When you load this image, it is going to compare this image with the database, and it is able to tell with some level of accuracy. You can see the result after it has been fed. It says it is a sports car with the 85% accuracy level. Okay. And I was trying to feed one more example of image which is having more than one items. Okay, it may be currently very easy possible to identify very simple single item, but the complication starts as you load images with multiple images. Let us see what was the result. It says a desk with a 36% accuracy, desktop computer, monitor, screen. Of course, the it is evolving. Maybe when you feed with the multiple components, it's going to take time to identify. I was curious to know. For example, auto components, you have 25,000 components to make a single passenger car. In such case, will it have the ability to identify individual items? Okay, that was in question, but I couldn't get still a satisfactory answer. When this image was fed, it says it starts with a wrong item like carpenter's kit, 12.9%, lope, buckle, reel, fiddler. So as you see, the evolve technology is evolving, and in future you may be able to identify such item and apply it to large extent in the manufacturing, also in supply chain and logistics. With this, I am concluding the session. This is a part of our program called Digital Supply Chain, where computer vision you can learn by using Python and AI. And you should be ready for the future if you're trying to apply for a job in a multinational organization or in consultancy. Knowing digital supply chain and what are the tools including supply chain analytics will help you in fetching a better job. Any questions, you can just reach out to me. You can see my WhatsApp number. You can ping up and talk to me. Thanks for watching.